everyone. So today we are working on Grade 3, Module 1, Lesson 18. And the goal here is that I can apply the distributive property to decompose units. Our focus is distributive property and problem solving using units of 2 through 5 and 10. You should be able to skip count by 3s, 4s, 5s, 6s, and we've been practicing some of the bigger ones as well. Remember, our goal is to apply the distributive property to decompose units. A parking structure has 10 levels. There are 3 cars parked on each level. How many cars are parked in the structure? Remember, we had talked about when you're doing multiplication, even with decomposition with units, you're always group counting. So we're going to be thinking of this with 10 levels and 3 per level, 3 cars per level. So it's groups of 3. Skip counting by 3 for this one. Okay, so what I've drawn here is called a tape diagram. So we're going to use this tape diagram to help us figure out how many cars we have or how many are parked in the structure. So you have 1 level, 2 levels, 3 levels, 4, 5, 6, 7, 8, 9, 10. I've drawn 10 boxes side by side. I could have drawn them up and down and pretend like it's a parking structure, but we mostly use them side by side. So I have 10 levels, and I also know that I have 3 cars on each level. So I'm going to use a stamper and make each star be a car. So there's 3 on this level, 3 here, 3 here, 3 on this level, 3 on this level, 3 here. Whoops, that one got on the wrong level there. 3 on each level. So what I have is 10 levels with 3 cars per level. So I could say this by saying, well, I need to know how many cars are on 10 levels. So I have 10 levels with 3 cars per level. That's pretty big. I would have to skip out count by 3 10 times or 10 3 times, we know commutative property. But I could also break this apart and use the decomposition method. So I could say, well, I have 1 group with 3, 2 3s, 3 3s, 4 3s, 5 3s. I could choose to break this apart right here and say, oh, I know 5 times 3 is 15. So I'm going to say 5 times 3 here. This should be times. So 5 times 3 equals 15 here. And I have 1, 2, 3, 4, 5 groups of 3 here also. And that is also 5 times 3, which also equals 15. And that makes this problem a little bit more doable. So now I can say, oh, okay. So this 5 times 3 and this 5 times 3 makes it 15 plus 15. And I know that that is 30. So the answer to 10 times 3 must be 30. There's lots of ways to double check that. You can skip count by 3, 10 times, 3, 6, 9, and just keep going until you get to 10. So your answer here would be 10 times 3 equals 30. Another little trick that you can do to solve something like this is what we've really done is broken apart the number of levels or the groups, the number of groups. And we broke it apart into 5 plus this other 5 right here. So that's a little trick. What I did was I said, oh, okay, I just took this and broke this into 5 groups of 3 and another 5 groups of 3. And I just added them together. So something like this can look a little bit overwhelming, but this is the same thing we just did a minute ago. We're using this decomposition or distributive property using tape diagrams and arrays to model 7 times 5. So I'm going to pause the video, and you can pause too and draw a tape diagram that shows 7 groups of 5, and you can show an array that also shows 7 times 5 or 7 groups of 5. So pause your video and I will pause and do the same thing. Okay, so I am back, and hopefully you were able to draw your tape diagram, which is this top one, and using the array model, which is this bottom one with the stars. So I drew 7, this number here, this is for this factor, 7 groups right here with 5 per group. So I did 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5, 5 5s, 6 5s, and 7 5s. And then I also did 7 rows of 5. So here's 1 row of 5, 2 5s, 3 5s, 4 5s, 5 5s, 6 5s, 7 5s. I showed it 2 different ways. Now for distributive property, we're going to want to add some numbers in here, and they kind of set it up for you. So the only thing that's missing are these parentheses. In distributive property, you want to add, because we're actually showing groups of numbers. So we could divide this up any way we wanted. I'm just going to take this one maybe and divide it right here and say, let's do, I don't know, 3 groups with 5 per group. So I could do 3 groups of 5, that stands for these 3 groups, plus another 4 groups of 5. So 3 groups of 5 is 15, right? And then 4 groups of 5 is 5, 10, 15, 20. 15 plus this 20 equals 35, right? So that would be equal 35. That'd be our answer. I'm gonna put that up here just to remind myself. But they also put this equal here and put another multiplication at the end. So it can be confusing. You have to watch these symbols. So what this is really saying is this 3 groups of 5 and this 4 groups of 5 is the same as saying 3 5s, 4 5s, 5 5s, 6 5s, 7 5s. It's the same as saying 7 times 5. So I know that 7 times 5 equals 35. So if I were to break this apart showing the same thing, I would take 3 rows of 5 and split it there. This shows 3 times 5 and this shows 4 times 5. Let's take a look at something like this. When you have something like this, you have 8 times 10. It's showing 8 tens. They're actually using those number bonds. Let me grab my marker. Okay, so we have 5 tens. We still need more tens to make 8 tens. These are the 2 parts and that's the whole. So 5 tens, you go 5 tens, 6 tens, 7 tens, 8 tens. We need 3 more tens. So for this little part here, if you had this paper, you would write 3 tens. You would write tens in there. That's 5 tens plus 3 tens equals 8 tens. So then you would write 5 tens plus, and then you would write 3 tens equals 8 tens. And you would say 5 times 10 plus 3 times 10 equals 8 times 10. 5 times 10 is 50. 3 times 10 is 30. And this part would say 50 plus 30, 50, 60, 70, 80. You would get 80. And so therefore 8 times 10 equals 80. And that's how you would find those using the number bonds too.